Hey guys, let's discuss new problem from dynamic programming, which is called coin change 2. So here you would be given one array. Okay, so let's say this is the coins array. So you have a coin of $1, $2 and $3. Okay, and you need to form a sum 5. Okay, so how many ways you can arrange these coins to form a sum 5? So that is the question, and it is called coin change 2 as well. So for example, if you have 1, 2 and 3, and you can take these coins multiple times, right? So the first way how you can give someone a change of $5, 1 comma 1 comma 1 comma 1, this way. Okay, I'll give all 5 $1 coins to them. Now second is 1 comma 2 comma 2, right? And third one is 1 comma 1 comma 1 and 2, right? And fourth one is 3 comma 2, right? Anything else do you find? No, right? Or you can find 3 comma 1 comma 1 as well. And then what else? That's it, right? So 1 2 3 4 5 ways. So 5 will be the answer. So this is what we need to find. So let's figure out how we can achieve that. Okay, so let me create a table for this. So what will be there in the table? 1 2 3 coins. Okay, and sum is 5, so I'll start from 0 0 1 2 3 4 and 5. Okay, now tell me one thing. If you wanted to give someone a $0 coin, okay, and you have a $1 coin with you, and you need to give someone $0, how many coins, $1 coin, will you give him? It's infinite, right? Or 0, correct? So here not the infinite coin. So in coin change 1 we were writing there infinite, right? But here how many ways you can give? So one way, which is empty, right? So one way, here one will come. Okay, $2 coin, $3 coin. Now if you need to give someone a $1 and you have only $1 coin, how many ways you can give him? One way. Okay, 2, again one way, 1 comma 1, right? Now for 2, see, 1 is lesser than 2, so you take whatever is we have calculated previously, so 1 will come. Now if you need to give someone $2 and you have one $1 and one $2 coin, so in how many ways you will give him? So now here is the recurrence relation will come. Okay, so what is the recurrence relation here? See, you will add the previous element with what? So $2 sum you need to form. Okay, and you have a $2 coin, so you will take one $2, so you will take 1 from here. Okay, and then not 1 from here actually, you will take 2 minus 2 is 0, and whatever at the 0th location you will sum that value with this previous value. That is our recurrence relation. See, dp of j equal to dp of j plus dp of j minus coin. Okay, so here the value will be 1 plus 1 2. Okay, now here 3, for $3 what it would be? 3 minus 2 1, right? So this one plus 1 plus, we are taking the previous element, 1 plus 3 minus 2 is 1, so 1 here, 1 will come here, so 2 will come here. Okay, and then same for 4 minus 2 is 2, so 2 will come here. So this one plus this one, 3. 5, it will be 5 minus 2 3. Okay, for 3 it is 2 plus 1, 3 will come here, right? Now here for $3 you take value as it is. Okay, 1 2. And now here, see, if you wanted to give someone a $3 coin, okay, $3, and you have this $1, $2, $3 coin. So first to go, 3 minus 3 is 0, and what is here on 0th location? 0 is 1, so 1 plus this 2, 3 will come here. Okay, similarly for 4 minus 3 is 1, so what is there for 1, and here 3, so 3 plus 1 is 4. Okay, now for 5 minus 3 is 2, so for 2 it is 2, and this 3, so 3 plus 2 it is 5. So 5 ways you can give someone this $1, $2 and $3 coins. Okay, so this is what and this is the solution for it. Okay, space optimization. So we have created 1D array only, and then you just iterate this loop. Okay, and then you write your recurrence relation, and then at the end just return dp of sum. So yeah, that's it. Thank you.